All right, this is Chapter 7, Part 1, Microbial Metabolism. So we're going to start by talking about a few terms here. Metabolism, Anabolism, and Catabolism. So don't get these terms confused. A lot of times people just automatically assume we're talking about one or the other when there are specific differences in these terms. So metabolism pertains to all chemical reactions and physical workings of the cell. So breaking down and building up, as well as some other things, but we won't get into that right now. Anabolism is the building. Think of anabolism or anabolism. I don't know how you want to pronounce it, but that is building things. So any process that results in the synthesis of cell molecules and their structures. So if we take part A and we take part B and we combine them, we build a new molecule out of those two parts, then that's anabolism. And that requires energy. We need to have some sort of energy currency in order for this to happen. So we need ATP there. Catabolism is when we break things down. We're breaking things down into smaller molecules. So we take part C and we break it down into parts A and B. And in this process, we're going to release energy. So think of catabolism as how when we eat, we take in, say if you have, let's say you have a grilled cheese sandwich and, you cook it up, you put it on the plate, maybe have a slice of tomato with it, a little bit of pepper on the tomato, maybe have a nice glass of tea, and you take a bite of the sandwich and you chew and you chew and you chew. And the whole point of chewing is to break down that fuel that we're going to need. So we're breaking down the cheese and the bread into smaller and smaller pieces. We swallow it. It makes its way down into the stomach, where the stomach churns and breaks it down using all of the stuff in the stomach, all the acids in the stomach, to break down that sandwich even smaller into even smaller pieces. And then it makes its way into the small intestine, where those smaller pieces, which are now small enough to be absorbed through the lining of the small intestines. So now we can use those nutrients that were basically extracted from that sandwich. So catabolism is a perfect example of catabolism is when we eat. Okay, it breaks the bonds of larger molecules into smaller molecules, and in the process, we release energy. So, once that sandwich is small enough, the bonds that are broken release energy, and it's stored as ATP. So, make sure you know the difference between those three terms and know that metabolism isn't the same as catabolism. Metabolism is all of them. Anabolism is building and catabolism is breaking down. Oh, and anabolism requires energy, catabolism releases energy. This is just an illustration of what we got there, and most of what we're going to talk about in this chapter has to do with this part right here, catabolism. So on to enzymes. Enzymes are catalysts, okay? So they encourage reactions. So it's very important to think of enzymes. When you think of enzymes, and my husband makes fun of me because he says I say the word coupon wrong, but I'm going to talk about coupons. And so enzymes are like a coupon. So and I'll get back to that in a second. So enzymes increase the rate of chemical reactions. They speed them up. Okay. Enzymes are not consumed in a reaction. They are just additives that are not consumed, and they do not become part of the product. They're tools in a reaction. Um, they also don't create a reaction, and that's kind of a confusing statement, but I'm not going to jump up and down about that. But what I want to kind of come back to the coupon thing. So, I occasionally will go to BJ's to load up on certain things, specific things that we use in the house, paper towels. I'll go in, I'll buy a big thing of eggs. But I don't go very often because I know that a lot of times I can find stuff cheaper in the grocery store. But when I do go to BJ's, I will always try to use a coupon. And of course, I'm big on stacking coupons because BJ's lets you do that. And that means if it's 3 tubes of toothpaste packaged together, and you go and cut your coupons from the internet or whatever, you can take 3 of those coupons with you, as well as using a coupon for BJ's. That's here nor there. I'm kind of getting off topic here, sorry. But coupons are, I think of coupons as a catalyst or an enzyme as a coupon, rather. In that, if I go to pay for something and I have a coupon, I use less of my cash. I use less of my energy when I'm using an enzyme. Okay, so because of an enzyme, when there's an enzyme participating in a reaction, then we need less energy. So with that, it increases the rate of chemical reactions, the enzymes do. It reduces the amount of energy, and I'm going to say that again. An enzyme reduces the amount of energy needed in a reaction because you're using your coupon. You're using your enzyme coupon. I don't have to take as much cash out of my pocket when I am using an enzyme. The same way I don't take as much cash out of my pocket when I use a coupon. So how do enzymes work? Enzymes serve as kind of like the space station, right? They're a physical site upon which substrates can be positioned for various reactions. So things attach to the enzyme, and the enzyme causes these things to either be bound or to break apart. So we need that enzyme, that physical site on the enzyme, in order for those reactions to happen. So the enzymes are larger in size than the substrate, and to define substrate, that the substrate are the reactants, we'll say. So the things participating in the reaction other than the enzyme. They present a unique active site that matches only that of a particular substrate. And you're gonna, as you go through anatomy and as you go through this class, or as you've gone through anatomy and you're going through this class, you're gonna find, okay, well, there's a lot of lock and key stuff in the body, and there's a lot of lock and key stuff in microbes. So the active site on a particular enzyme is only going to work for a particular substrate. The enzymes can participate directly in changes to the substrate. So again, they may participate in changes to the substrate or the reactants, but they're not consumed. These enzymes are not consumed, and they don't become part of the product. So these enzymes can be recycled. They're used once, and then they move on to the next reaction, and they're used and they move on to the next reaction. And eventually they will be worn out and disposed of, and more will be made, but that's, something that we'll talk about later. And as I just mentioned, they can function over and over again. So they can do their thing and just move on and do it again. All right, so there's a couple different structures for enzymes, but we'll talk here about conjugated enzyme structures. So basically that means it's the enzyme and there's something else there that helps it do its job. It's like a little assistant. Okay, and here we have the apoenzyme and then a cofactor. And then we have the apoenzyme and a coenzyme. Sometimes we have a coenzyme and a metallic cofactor. So a conjugated enzyme is basically one that has helpers along with it that may be either a cofactor or a coenzyme as the helpers. So simple enzymes are just a protein, just that purple, just the purple here would be a simple enzyme. But if it was a conjugated enzyme, it would be that purple, which is the protein, and some sort of other non-protein molecule. A holoenzyme, just terms here, is a combination of a protein and one or more cofactor. An apoenzyme is the protein portion. Okay, so remember this is the apoenzyme. It's the protein portion. And cofactors are either organic molecules called coenzymes or metal ions. So when we talk about cofactors, it's either the metal ion or the coenzymes. Sorry. So either coenzymes or metal ions. All right. So we're going to stop there and we're going to move on to a little bit more of how these things work, to part 2.